Do you ever wonder how the magnitude of earthquakes are measured? How do you think scientists are able to determine magnitude levels? Well, the scale that they use is called the Richter scale. The scale is used to measure the magnitude of earthquakes. It is a logarithmic scale based on the amplitude of waves recorded by a seismograph. The lower the magnitude level, the lighter the earthquake is, and the higher the magnitude level, the stronger the earthquake. An equation that can be used to model the scenario would be m equals log I over I0 or I naught. M represents the magnitude of the earthquake, I represents the intensity of the earthquake, and I0 represents the intensity of an earthquake with a magnitude of 0. A simplified version of this equation is m equals log I. The I represents the ratio of the intensity of the earthquake. This is the graph for the original equation, m equals log I. And this is the graph for the inverse relationship of the original equation, which is 10 to the power of m equals I. Scientists use the scale to measure the magnitude of earthquakes. The magnitude level usually ranges from 2.5 to 8 plus, and the machine that is used to measure is called a seismograph, which looks something like this. So the first question about the scale is, a scientist is trying to measure the magnitude of an earthquake with an intensity of 10 to the power of 6 I0. What is the magnitude of this earthquake? The second question is, an earthquake measures 4.5 on a Richter scale, A, in San Diego, and another earthquake measures 8.5 on a Richter scale, B, in Tokyo. How many times stronger is B than A? You can pause this video to try those questions out. So this is the answer for the first question. You will use the original equation m equals log I over I0, and since 10 to the power of 6 I0 was the intensity of the earthquake, you will substitute that to I, which will give you m equals log 10 to the power of 6 I0 over I0. Obviously, you can cancel out the I0s and you will be left with m equals log 10 to the power of 6, which will give you a magnitude of 6. So this is the answer for the second question. I converted the original equation to exponential form, which will give you I equals I0 times 10 to the power of m. Since there are two different earthquakes, A and B, with different magnitudes, 4.5 and 8.5, you will substitute this value to m of the equation, which will give you I0 times 10 to the power of 4.5 and I0 times 10 to the power of 8.5. Now, since we are comparing these two earthquakes, you will divide them, IB over IA, which will give you I0 times 10 to the power of 8.5 over I0 times 10 to the power of 4.5, which equals to 10 to the power of 4 since we are subtracting exponents, meaning earthquake B is 10,000 times stronger than earthquake A. Some interesting facts about the Richter scale is that the majority of the earthquakes which have been recorded till date have been less than 3 on the scale. They are actually tremors that are not felt by humans and are known as microquakes. The largest earthquake ever recorded on a Richter scale was the Valdivia earthquake with a magnitude of 9.5, located at Valdivia, Chile. This is an image of the earthquake that happened. This is the second strongest earthquake, the Great Alaskan Earthquake, with a magnitude of 9.2. The third strongest earthquake was the Indian Ocean earthquake and tsunami with a magnitude of 9.1. This is the fourth strongest earthquake, the Tohoku earthquake and tsunami in Japan, with a magnitude of 9. Lastly, the fifth strongest earthquake was the offshore Mal in Chile with a magnitude of 8.8. These were some of the top 5 strongest earthquakes. Thank you for watching this video.